Okay, we're going to talk about tangents. So that's just a line that touches a circle at one point. Okay, so a line and it touches a circle at one point. Okay, so where's my tangent line in this picture? It's right here. Okay, so the line's going to be perpendicular. Remember, perpendicular, that's a 90-degree intersection. So where do I see that in the picture? Right here. Alright, to the radius. Where do I see radius? Right here. Point of tangency. That's, I'll do it like this. Point of tangency, it's a point where the line is tangent, so right there. So let's read this. If a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. Okay, so how are they going to apply this in problem solving? You know, when you're looking at these things, you're like, okay, listen, your problem solving should be, what information am I given or do I need? In particular, I look at the x. It's an angle. And then I'm like, well, what is it an angle of? Oh, it's a triangle. And then I start going through, what do I know about angles of a triangle? Because I have another angle right here, right? So I'm like, okay, well, I know if I knew all three that I could, you know, take the sum 180 and find out what's left, what's missing. So then I'm like, well, how would I know this, right? And then hopefully I'm looking at that and I'm saying, man, that looks like it's 90 degrees. And I can grab another sheet of my paper at my table. And I'm like, yeah, that definitely looks like 90 degrees. Oh yeah, I have a theorem that says that if a tangent line touches a circle at the radius, if they both intersect at the same point, that's not going to be 90 degrees. Okay, so I'm adding that. And now I'm just subtracting from 180 to find that last angle. Okay, all the angles in a triangle add up to 180, which makes my last angle 33. If you're the type of student that really likes to use an equation, you could have written an equation out here. You could have said my unknown angle plus 57 plus 90 equals 180, and you could have done your algebra. Alright, so x is going to equal 33 degrees. And I look at my picture, should always be my last step. Does it make sense? Yeah, that's an acute angle. Okay, so here's another one. Alright, again, let's go through those questions that you're asking yourself as you're problem solving. Okay, first I look at my picture, because if I know what if I see an x, if I see all the information I need, I might not read, but I don't have a whole lot of information here. So then I look and it says NO, line NO is a tangent to circle M. A circle is named by the center point. The length of MN is 17. Okay, so I'm going to put this in my picture for sure. And the length of NO is 15. There's NO. I just put that in the middle. That side's 15. Okay, find the radius. Radius. What's the radius? So I need an x somewhere if I'm going to, know what I'm doing here. Find indicates an unknown. The radius. Oh, the radius is from the center to a point on the circle. Remember, too, that you have your formula sheet that you can look at if you forget. I'm going to put an X right there because they want me to find it. Alright, so now I'm looking at this and I'm thinking, man, these are all sides of a triangle. That's a side, that's a side, that's a side. If it was a right triangle, I'd be able to use Pythagorean theorem, right? So, is it? Take another piece of paper, put it up there. Does that seem right? How would I know that's a right angle? They didn't tell me that. Oh yeah, that's a radius, that's a tangent line. Yeah, there's a theorem that says that. And then you can go ahead and solve this with Pythagorean theorem. Remember, the most important part of Pythagorean theorem is going to be finding what goes in for C, the hypotenuse. Go find your opposite side there to the right angle, that's going to be C. So when you do your algebra here, you're going to have x squared plus 15 squared equals 17 squared. So I can't do these at the same time. They're on different sides of the equal sign, right? So 17 squared. I'm working up this time. Okay, I have to subtract this from both sides to find x now, because I gotta remember I want x alone. Still not alone, but it'll get closer, so subtract this from both sides. And now my last step is going to be to square root that, to undo the square. So square root of 64, and I get x equals 8. And I look at my picture and make sure that I like it. You know, this picture might not be exactly to scale. So that's my radius. Alright, let's go ahead and talk about one other type of intersection with tangent lines. So if two tangent lines intersect, so remember here's my tangent. Tangent lines intersect the circle at one point. This other tangent line over here. Alright, so they're going to intersect each other here. Okay? So this says that if they share a common endpoint, then the two segments are congruent, meaning this has to be the same as this. Okay, I call this the ice cream cone one because, you know, this looks like an ice cream. The other types you're going to see with lines that intersect are going to involve, you know, this isn't an ice cream because how can the cone go through the ice cream? Same here. How can the cone go through the ice cream? This one's the ice cream cone. So when you hear me say ice cream cone, I'm giving you a hint. I'm saying, hey, this is the easy one, right? Do those look the same? Again, problem solving, you can start using, you know, check this out. Measure this. Measure this. You know, they look the same. Oh yeah, that's the ice cream cone one. I've got a theorem about that. So how can we see that in some problem solving? Here we go. They're intersecting. Okay, oh yeah, this is an ice cream cone. So these have to be the same. So what is x? Right? Okay, over here. Okay, now my brain starts thinking that I would really like to use an equation if I see variables like this, variable expressions. So is something equal to something, or do I know what those two things are going to add up to? Where is my information? It's on a side. This is on a side. This isn't a triangle, but oh, wait a second. I bet these are the same. This is my, turn it upside down if you need to see it. That's my ice cream cone. Okay, so what do I know about these? I know that they have the same length. So I'm going to set up an algebraic expression, or I'm sorry, equation. I'll work down this time, is equal to, this length is equal to this length. I like to get my x's together. If I move this one, the smaller one, I'm actually going to keep everything positive, which is something I can do pretty easily in geometry. 6 equals 10 minus 6, 4x. And now I want x alone, so I want to move the 30 over here. It's negative, so I'm going to add it to make it 0. And the opposite of multiplication to finish getting x alone is division. The inverse operation, so I've got x is 36 divided by 4. And this is just asking me for x, right? Find x. But you know that it doesn't take very long to go and check that. The mistakes you might make here are going to be minor. You're going to be able to find it. So let's go back and use our calculator to check. I'm going to now find this length and make sure my algebra is right. So 6 times x. X is now 9. So I'm just substituting. 6 times x plus 6. Some students use parentheses, that's fine. And then 10 times x is 9 minus 30. Okay, so I got 60 for both, which is exactly what I wanted to happen.